Hi guys, welcome back to the first major installment in this DIY CNC build series. As you can see here, I've already hit one of the first major milestones in the project, which is the machining of the parts and assembly of the parts to create this Y-axis frame here. As you can see, it's all put together. It's nice and strong, sturdy, and it's going to be great for this machine. This video is going to be a longer one, and that's intentional. The reason for that is I've tried to keep everything as raw as possible so that you can see all the details of what I'm doing here. I've tried to explain myself along the way as well, and I think you're going to find it very useful, particularly if you've never worked with any of this material before. So strap in, grab yourself a cuppa, and let's build this thing. Right, so I'm now in a position where I can start working on the real machine parts. I'm very happy with my practicing over on the pillar drill, comfortable with all the types of holes that I'm going to need to drill here for this project, and yeah, I'm ready to get stuck in on these parts. So as I mentioned before, this is where I'm going to start, and these are the cross-section pieces for the Y-axis. You can see here as well, I've had to play around cleaning this surface up, trying to get them as flat and smooth as possible. I haven't done these ones, I'm going to wait till after the machining to do them. I just wanted to have a go, again, get familiar with the tools and stuff. And you can see this piece in particular is a lot cleaner in terms of where it's been cut. That's really important going forward, because even though these have been cut, they're not cleaned up very well, and for a project like this where I'll have joins at a 90-degree angle, I need to make sure that this cut is perfectly square and has been cut straight. But I also want to make sure that there's no burrs or anything around the edge here that could potentially affect the angle or the join of such a part. So everything needs to be cleaned up, even though it's already been cut. That's kind of half the work, because you have to make sure everything's flat. And in this case here with this part, sanded this down and polished as well. It's super smooth. If I run my finger on this one here, you can almost feel the imperfections on it, whereas this one is perfect. So I have 6 of these to start working on today, and that's what I'm going to do. So I'm going to start with the whole Y frame. That's the first thing I'm going to build and bolt together. And what I have here, I'll zoom in for you here. So this here is a technical drawing, and I've created this in Fusion 360. As you guys know, I've designed the CAD model and everything myself. Based on that, I had all these parts cut. So in Fusion, what you can do is, for a specific part like this one, which I've isolated here, you can create this technical drawing which provides you with all the measurements and details that you'd need to create the part in real life, in terms of machining and drilling the holes. So for every part on this machine, what I'll do is I'll create a technical drawing just like this one. That should make it easier for people who want to do the same thing but don't necessarily understand the CAD or how to read measurements in the CAD software. This is kind of an old school approach, and this is common in machine shops everywhere. If you're working with a piece of stock like this and you're making a bracket or a faceplate or something, generally you would, if you were a machinist, you'd be provided with a document like this that gives you everything you need, and then you just use your skills on your machinery and your tools to create the part, because you've got all the information. So you don't need any understanding of CAD to be able to do the work here on the parts. I'll share these probably toward the end of the project, where I know everything's working and completed, and that should make it easier for you guys who are interested to try and recreate what I'm doing here. So these will all be available. What's great about these as well for some of the smaller parts is I've made this 1-to-1 scale. So if I lay this out here, it's exactly the right dimensions in terms of the height and even the depth here on this one. So that's handy as well for sort of reference. When you have a part in the real world, you can sort of put this next to it and go, okay, I can see roughly what I've got to do here. So on this part in particular, you can see quite clearly that I have 2 holes to drill, which are going to be M8, and I have a counter bore that goes in there as well, because like I did on the practice parts, these are going to be sat face down with the bolts coming up. So the bolt needs to sit above the base plate here so that the whole part can rest on my table. You can also see that on the end pieces I have to drill an additional 2 holes, and you can see the depth of how much they go in there. So they go into the part by 10mm, and the holes there again are M8s. And that's only on the 2 end pieces, because what that's for is a bracket for a plate like this that will hold the bearings for the ball screw. So what I'm going to do now is get started machining all 6 of these. I have to do this on each end. I'll then start machining the larger Y-axis parts, and I should be able to bolt it together. Okay, so as you can see, what I've done here is I've used the tools I've shown you in the previous video. Used this as a reference to create my measurements. I've marked out and punched where the holes are going to go for this part. So what I'm going to do now is just go ahead and create these holes for this piece on the pillow drill, and then I have to do this another 11 times. Okay, so what I'm going to start with here is an 8.5mm bit, because what I found through my practicing is that the boring bit has a guide on it which is approximately 8mm, but if I drill an 8mm hole, it tends to stick a little bit in there, and it could be because the drill is lower power. So to speed the boring process up, which can take a little longer, I'm going for an 8.5mm hole, which will then allow this to guide in a lot easier, speeding up that part of the process. And also, this isn't a bad thing, because when we're doing things by hand here, there's always going to be an element of human error. So when we're actually fixing the frame together and bolting everything up, we've got 0.5mm of wiggle room where things don't have to be perfect, but they'll still be able to bolt up. So that's what I'm trying to do here. If you're trying to do everything down to millimeter accuracy, or you know, 0.1mm, when you're doing it by hand, you're just not going to achieve that. So you have to allow yourself that little bit of wiggle room to make the build process a bit easier. So here we go. I'm going to do the first 2 holes here as the main drill holes, and these aren't going to be tapped because this just drops straight through, and then the thread will be on the other part that this is bolting to. So I'm going to go ahead and create these holes. As I've said before in the other videos, use plenty of oil, take your time, there's no rush. So I'm just going to quickly double check the measurement there, make sure that it's accurate. That looks good to me. And you always want to check that before you go straight in, because if it is off, you can make minor little adjustments before you do that. So I'll go ahead here now and make the second guide hole. There we go. Again, switch off. I like to double check, make sure it's correct. Looks good, 12.5, which is exactly what we want. Now I'm going to go ahead and drill all the way through. So plenty of oil. Again, add oil to your bit if you want. And let's go. go, we're all the way through the first hole. Okay, so we're going to go ahead and do the second hole now. So there we go, we're all the way through and done with our first holes. So I'll clean this up. As I've said before, keep everything clean, so wipe all this off. And also make sure that your work surface has no chips on it, because you want to make sure everything stays nice and level. Now that we've got our main holes drilled here, these essentially act as pilot holes for the boring. So I have the boring bit installed, so you'll use that as a guide to go in. And I'm going to be going down to a depth here of an M8 bolt, which is approximately 8mm. And I'm going to go and use this as a guide as I go to check it. So remember, lots of oil. When doing these ones, it's often useful to clamp it down. You can see that is nearly there, so we need to go a bit further. So pop a bit more oil in there, line it back up, and off we go. You can see that sits nicely below. We can also drop the bolt right in. You can see it sits in there nicely. That's good enough for me. So let's go ahead and move on to the second one. That'll do it. And there we go. Okay, so you can see there we've completed our part. We've drilled our holes. So I'll take this over to the other bench now and I'll show you that up close. Okay, so here we are. You can see I've created my first part in correspondence with the drawing. So I've drilled 8.5mm holes there, which gives us a little bit of wiggle room for the bolt, for the 8mm bolt when we're bolting everything together. This accounts for the little bit of human error that is inevitably there when we're doing this by hand. And obviously then the counter bore that these bolts will sit in. So here we go. If I put the bolts in, you can see that they sit nicely in there, flush below the surface, and that's it. It's as simple as that. If I turn it on the side, you can see there, they're nice and straight. If I pop the bolts out, and I just show you the underside. Nice clean holes there on the bottom. So now what I'm going to do off camera is go and do this for the other 5 bars on each side. Okay, so after a lot of drilling, here are the 6 parts all done. Apart from the drill holes on the side, which I'm going to leave till I've done these plates. So I can use these plates as a bit of a jig to get those holes as accurate as I can. But I've done all 6 of these. They're all looking very good. The bolts go in very nicely. They just sort of drop in. There we go. And that's the idea. So this will sit nicely this way up, just like this. And these will then bolt to those large Y runners that we've got on the sides. And then we'll bolt the linear rails down to them later on. So the next step now is to start working with this much larger piece here, which is going to be where the linear rails bolt onto. And these are going to bolt from the underneath, as I said. So they'll run like this and bolt straight on to this piece right in the center. The idea being there that I will use these now to mark out the holes where I need to drill. And it's easy to do it this way, especially when you're working by hand, because it's going to help eliminate a little bit more of that human error. If I try to measure out again here and just drill them and hope that they match up, chances are that they won't, just because it's been done by hand. Obviously if they'd be a machine, they'll be perfect, but when I'm using the drill press here, there's always a little bit of error, so doing it this way just makes it so much easier. As you can see here, I now have all the parts I need to build the base frame of the machine. We have the Y runners here, which are the largest pieces, and then we have the cross-section parts, which just go like this, bolting the machine together and ensuring that it's nice and sturdy and strong. Before we go ahead and do anything with these, first thing we'll want to do is try to smooth out these parts as much as possible. I've already smoothed one of them out. I did a little test run of that right at the start when I got the materials. And you really can feel a difference here between these parts in terms of how smooth they are, particularly these larger pieces. So wherever these were manufactured and cut, if I run my finger across this, I can certainly feel all the little bumps and imperfections caused by the manufacturing process that these went through. We need to eliminate that, because these parts, as I said, are going to join like this. We want to get everything as flat and square as we possibly can do by hand. So in this case, for example, these pieces are going face to face. So I'd be interested in smoothing this side out and removing any imperfections, and the same here, so that when these two mate together and get bolted, that we get a nice strong join and they're perfectly flat. In some instances you also want to do the same with the ends here, because whenever these are manufactured in the shop or cut, you're kind of relying on them in the sense that they had their blade set up perfectly square and straight when they did this cut, and in some cases that's not always true. There are one or two pieces here that aren't perfect, so you want to take as many measures as you can to make sure that ends like that are straight. For these parts in particular, that isn't as important, because as you can see, this is the bottom end of the frame. It'll all be flipped upside down. So these are not necessarily joining to anything or mating with another surface. These ones are. So these are the ones I'm prioritizing. But in other instances where we would have parts join in like this in a different way, you would want to make sure everything is square. When trying to get the squareness of the frame here, I will be using obviously one of these each end initially to get that squareness, and in that case I will ensure that the ends on both sides on both pieces are perfectly square, because we're using those two lengths to determine how to line this up and make our markings for our drilling. So the end pieces must be square, because what we can do is we can use a test block like this one, for example, and what you do is almost use that as a guide, because we know that's a flat surface. You can try and flatten everything up and make it square on each of the ends. So by having that perfectly square, we know that when this is at its furthest point, we know we're good. So to smooth all these pieces out, what I'll be doing is using an orbital sander. These are really easy to use. It's a rotationary sander. I'm sure you've used one before. But if you haven't, basically you can buy these sanding discs that just pop on there, and you can go and sand down your pieces. Now it is important doing this by hand that you don't really want to put any major force down on that. You just kind of want to let it do the work and let the weight of it do the sanding on its own. If you start putting a lot of force, you may find that you're not keeping it too flat and you could start to round some edges off. Avoid doing that. Let the weight of the tool do the work and just guide it where it needs to go, as opposed to really, putting some effort into it. So I'm going to do that on all of these pieces. I'm going to go around the whole machine and every part. I have 4 grits here that I'll be using. I have a 120, a 240, a 1500 and a 5000, and that should give you a very nice finish on these. And as I said, I've done one already at the start, and honestly you obviously can't see it through the camera, but when I run my finger through this one here and then this one, the difference is astonishing. It is a step that could potentially be skipped, but if you're going through this process anyway and you've spent all the money on these parts, you might as well go the extra mile, right, and make sure that it's as good as it possibly can be with the tools and experience that you've got. Okay, so there we go. After hours and hours on the orbital sander, I've got these parts all polished up, nice and smooth. There's no rough edges or burrs. It's safe to handle. And from here now I can start sort of measuring out the frame itself and where the holes are that I need to drill on these pieces. So I don't know how well you can see it on the camera. Maybe if I move them around a bit. But you can see there's a lot of smoothness to these now. You could polish these beyond this and have almost like a chrome-like finish, but that's kind of unnecessary in my opinion. I may do that for the gantry backplate just because it'll look nice and you can see that. This is all going to be on the bottom and mostly hidden apart from these side ones, so I'm happy with that for now. And as you can see, they look great. All the holes are marked out, everything's smooth. So what I'll do now is I'll do my best to try and arrange these as they would be on the machine. I'm going to start with the ends, try and get as square as I can. I'm going to make the markings for the ends first and drill the holes there too. So ideally what I want to be able to do is bolt the frame together as a square first of all, or rectangle, and then I'll make the markings for the other cross section pieces afterwards, because then I know it's held in a perfectly square position. So exciting stuff, it's coming along. The machine is going to now start to take form. So let's go and do that. I'll try to record as much as I can, or at best what I'll do is do some voiceover of some of the filming. So enjoy. So this is the underneath of the frame, and as I said, we're going to be doing the end pieces first here. So what we want to do is bring these together. So these are 930mm in length. So the first thing I'm going to do, regardless of these pieces initially, is get these longer pieces exactly that apart to the ends of each. So we can do that with a simple tape measure. So in this case, I want to be taking a look here and bring them as close together as I can. So looking at this, they're already too far out, so I need to bring that in. Only roughly at the moment, just get it as close as you can. There we go, that's that side. Same the other side. So we got 93cm that side, 93cm this side. Now from there, what we can try to do is line these up. And like I said before, they should be, if you've done that measurement right, they should be pretty much square here. So all we really need to do now is, again, use a block. So you can shift these further over. We know that this is perfectly flat. We can just push that up against it, covering both parts, and make sure that we're square there. We can do the same here. And then we want to do the same on the ends. You might see it shift a little bit, and that's okay. You're going to have to go and do this a few times. You're going to have to do that side and then come back, and then double check yourself, and then triple check yourself. So same this side, we want to do the same thing. Make sure you've got plenty of space. Luckily, I built this so that it can roll, and I can get all the way around the machine. And you can see why that's useful now, when I need to be moving around checking everything out. If this was wedged up against the side here, I'd have a real hard job checking these. So again, same thing, we're just going to square ourselves up best we can. That side's good. Come back over to this side, square this one up as well. So we got 93. You can check it in the middle also. Remember to just keep measuring as much as you can. Always trust the tape measure over your other parts. Don't trust the length of these entirely. The tape measure is not going to lie. So now what we're going to do is measure this corner to corner, and that'll give us a true square in terms of the skewness of this. So if the measurement from here to here and here to here are equal, then we have a nice square frame here. And at that point we'd make our markings, drill our holes, and we bolt these in place. And again, another comment I'll add here is those minor adjustments there have been made easier in this case because we're bolting this together, and I've left 0.5 millimeter of wiggle room in these bolt holes. Whereas if you were welding this, what we'd have to do is get our square, clamp it, hold it exactly in place while we do the weld. Whereas here we've definitely got that bit of play, which is going to allow us minor adjustments if there are any sort of human errors in there. So let's now measure corner to corner. This can be a little difficult. Just be gentle, make sure you don't pull anything out of place. You don't want to pull anything too hard. So you can see what I've got here. Try and keep this as straight as you can. 152 centimeters. So now let's do the same this side. Again, we want to go corner to corner. Very gentle. And in this case we don't. We have 151.5. So what that means is we need to make an adjustment. Looking at the table, it looks like we're heading slightly out that way. So what we want to do in that case is move these in a little bit to try and adjust that. So we need more length on that measurement, and then bring the parts with it. And now we're going to go around and do the exact same. So we want to make sure we've got 93. So let's bring this back over, and we'll measure to this side this time. Bring this out ever so slightly till we get 93, which we now have. Perfect. Let's square up. Let's double check our measurements once again. Should be 93, perfect. On this side we should also have 93, that's perfect. So let's do our corner to corner again. 151.8. And on this side we're looking at 151.85. There's a tiny adjustment that can be made, and I'm going to do it just because it's me and I have to, but that probably would suffice. But seeing as we're only going to do this once, I'm going to make that last adjustment, and this is like 0.5 millimeter we're talking about here, so very fine, but I want to get it right. Let's do our measurement one more time. I'm pretty confident we've got it this time. 151.8 on this side. 151.8. We've got it. Perfect square achieved. So everything is absolutely bang on now. We've got 930 there. Just double check everything. 930 there, spot on. And up here we're looking at 930. Okay, so there we go. We've just achieved perfect squareness here with just a tape measure and a few simple tools. Everything is absolutely spot on. It looks great. Don't let this sort of put you off, because this is an overhang here on the worktop. And again, don't use your worktop as a reference, because there's no guarantee that these are straight if you didn't cut them straight. You have to use the measuring tape, measure in all places, and the most important one, corner to corner, because when that's right, you know you have a square. So next job is to have this bolted just like this. So what I'm going to do is use these holes here as a guide to create those drill holes ready to be done on the drill press. I'm going to do some M8 taps in those holes, so I'm going to be drilling 7mm holes and then tapping an M8 thread into those, so we've got a nice solid thread that we can tighten up securely. Same on the others, so there's going to be 8 holes in total. And then once we can bolt this in place, we know it can hold that true square position, and from there we can mark out the other cross beams, pull everything off and drill those out as well. Another thing you can do here, of course, to further validate what you're doing, is just take a square and you can line this up on the edges here. So you can look at this and determine if it is truly square or not. I can see there that that's nice and square. Right, okay, so what we're going to do now is mark out these holes in the exact position that we've left them in. Depending on your setup, if you're able to clamp in place, for example, by clamping underneath to hold it in place, you can do that. I don't have clamps that large, but I'm happy doing it this way. You can, if you want to, mark them out. If you can find a pen that has the right size ridge here for you to insert into the hole to get a perfectly central hole, then that's a perfectly fine method to use. In this case, what I'm actually going to use is an 8.5mm drill bit, and this is the drill bit I use to make the holes. So obviously that fits into these holes perfectly central. So that means I can mark out on here. So for example, on a block like this, if you really push the drill bit in and twist it, it will leave a hole similar to the center punch. What I wouldn't want to do here is use the center punch, because one, you've got to eyeball the center point itself through the hole, which is difficult, and you've also got to whack it, which could shift things out of place. So you want to be as delicate as you can doing this, which is why I've chose to use this, because I know it'll make a perfectly central hole. And we're essentially using these pre-drilled holes here as a jig to make sure that the holes we drill into this piece will line up and it'll all bolt together nicely. So as I said, this is an 8.5mm bit. I'm going to use that to do the markings, and then I'm going to use a 7mm bit to drill out those holes, and we'll tap them with an M8 thread. So you don't even need a drill or anything to do this. You can do it by hand. The marking is that easy to make. So that's what I'm going to do here. Slowly but surely make our way round. Just place the bit, hold it central, and just give it a twist, a couple of turns. All the holes have been punched, so now it's time to go and drill. Okay, there we go guys, so I managed to successfully drill and tap the holes for each of the corners. We have 2 bolts in each corner, which prevents any sort of swaying, particularly when you just have a square. So now that we've got our outer perimeter of the frame square and solid, again double check by using the measuring tape corner to corner. I did put probably more time than I should have into this part, but it is really important to try and get it as square as you can, because this ultimately is the foundation and the rest of the machine builds up from this. So if you're kind of wrong at this stage, it's hard to get the rest of it right. You can account for some minor adjustments obviously when we bolt the linear rails on to the other side here, but still ideally we want that to be perfectly central all the way down and not sort of tapering off to one side to account for any error. So as far as this goes, I'm extremely happy. So what I'm going to do next is take the other pieces, work out sort of where these are going to go in terms of their distance apart, and I'm then going to go through the exact same process that I've just done, except now I'm going to be making sure they're straight. And again, we can use the square to do that because we just want them to be 90 degrees there, and we can use our measuring tape between these 2 points. And I'm going to add the other 4 of those in, which should really give us a solid rigid frame at that point. So upon undertaking this process so far in drilling these holes, one of the things I've noticed is extremely beneficial is to obviously first mark out your holes with a punch. That's the first step. I found that rather than go straight in here with a larger bit, it's much more effective to work your way up, in the sense that I've created a punch hole there large enough for a bit like this to fit into and start a smaller cut. So what I would do is drill that down a considerable depth, maybe 10 mil in each hole, and then you can use a bit like this, which is a slightly larger countersink bit. So with your existing hole that we've created with the other drill bit, you can use this to then create a countersink hole big enough for your larger drill bit to fit straight into. That way you're starting off accurate with a smaller bit, and you're building up to the larger bit, meaning that when we use this bit, this is going to be as central as possible, giving you a much more accurate hole. So I'm going to go ahead and do that. I'm going to create the first 2 holes here with the smaller bit. The benefit of doing a pilot hole as well is that it does make cutting easier when you move up to the larger bit. So I'm going to start the cut first of all. I like to start the cut without oil initially so I can see exactly where the bit is going. Sometimes when you put too much oil, you can't see the hole and it makes it more difficult. So I'm just going to go in with that gently. Start to make the guide hole for this bit. So there we go. That'll do for the first hole. Let's move over to the second one. Same thing, line it up. It should fit straight into that hole. That'll do for our pilot holes, and now this is going to really aid in creating a much more accurate guide hole. So again, you want to line it up as centre as you can get it. There we go. The hole will guide it anyway, but it's good to get it as close as you can beforehand. Add a bit of oil. I'm going to add it to each hole, and we're going to go for it. There starts to cut nicely. So if we wipe this off, what you can see there, if I now take this bit, the bit can actually insert into the guide which is going to make that a perfect guide hole for this going down. Don't worry if you go larger than the diameter of the bit, because all that does is it acts as a nice countersink and it gets rid of any burrs as well, so it's a win-win. So I'm going to do the same for the other hole. Let's check that one out. Again, perfect. So now from here what we can do is take this one out, insert our 7mm bit, and there we go. Now we should be able to drill some nice holes for our M8 thread. And you can see it just, as soon as you put that down, it guides it straight into the hole where it's supposed to be. There we go. If you just look at that, you can see straight away that's guided it perfectly. Exactly, it's going to be accurate now all the way to the bottom. There we go, that's the first one. Perfect hole. Now what we'll do is we'll go and do the second one, line it up. See the bit just guides it straight in. Switch it on. There we go, you can see there what we have are two perfectly accurate holes ready to be threaded. Okay, so here we are, everything bolted together, nice solid frame as you can see. It's very heavy. In terms of how it's turned out, I'm super happy with this. It all went together very nicely. I'm still square corner to corner, and I've tested it here as well with my set square, and it all looks good. So from here, obviously this will be flipped over, and the next stage of the project will be looking at getting those linear rails on. But before we do that, I'm going to need the gantry. So the next step is to start constructing the gantry. So we've got the big back plate, which I have down there. I can show you that. So this is the large gantry back plate, and as you can imagine, this will be up here like this, with some big side plates. So what I'm going to be doing is cleaning this up, cleaning all the side plates up, and I'll be doing the machining required on this. That's going to be great because I can use that as a jig then to ensure that the linear rails are going to be straight and there's no binding. So I've just flipped that over, as you can see. I was able to do it by myself. It is very heavy, so getting a hand wouldn't hurt. But you can see this is what we're going to be dealing with. I have my two long waist Y-axis pieces here, and then obviously the cross sections for that. I also have the linear rails here, and I'm going to put them on so we can sort of see what it's going to be like. So I'll put this one on here roughly. And there we go. So obviously these aren't lined up perfectly at the moment, because that's going to be the job of using the gantry as a jig. And what that'll allow us to do is I'll be able to place the gantry on one end and put two of the bolts down, slide it all the way along the other side, and the gantry will keep everything square. So then I can put another bolt this end, and once you have four corners bolted, move it back to the middle, do a couple in the middle, and that way you should be able to move backwards and forwards with no binding at all. So that's the way I'll be approaching this. Starting to look good now, it's getting there. I'll do some close-ups so you can see that a little better, but the machine's looking good, and I think you can really see how sort of solid this is going to be. Again, if I show you this gantry piece, you can imagine what we're dealing with here. Very robust machine that's very capable. So there we go, that's where we are so far. I hope you've enjoyed it up to this point. I've tried to be as detailed as I can. It is quite difficult to document this while trying to actually do it and do a good job, so I'm doing my best. Hopefully you've been able to follow up till this point. The other thing I'm going to be looking to do in terms of the linear rails is ensuring that this top surface is as flat and level as possible. And one of the ways I can do that is use something like a dial indicator. I can actually put a dial indicator on one of these bearing blocks and sort of slide that up and down and try to detect any high points here. And if I find any high points, I can sand them down and try my best to just get them as flat as I physically can, and the same on the other side as well. That way I'm doing everything I can to ensure that the machine is as level as it can be. These will be coming off obviously for me to drill and tap some holes. I have a couple left to do on the side here, so I haven't fixed this completely together yet. I will also be using Loctite when I put these back on for the final time. That should hold everything together that little bit better. So there we go, I hope you enjoyed the video. As always, thank you so much for watching. Hope you learned something, and I'll see you in the next one.